All right. X equals, for axis of symmetry, negative b over 2a. So b being 8, negative b over 2 times 2. So we have negative 8 over 4, which is, of course, negative 2. So axis of symmetry, we have x equals negative 2. So then for our vertex, we know that negative 2 is the x-coordinate. Then we're going to plug that into the equation to figure what the y value is. So 2 times negative 2 squared is positive 4, times 2 is 8. 8 times negative 2 is negative 16, minus 7. So 8 minus 16 is negative 8, minus 7 is negative 15. So negative 2, negative 15 is our vertex. As far as a max or min, we see the a value is positive. That tells me this parabola will be opening up. So the vertex will be down at the bottom, which is a minimum. So we would answer min. And then for the value, it's whatever the y value was the vertex. We just plugged it in and negative 2 in to get negative 15. Negative 15 is the value. The y-intercept, that's your c value, which is negative 7. So 0, negative 7, or simply negative 7 would suffice. As far as domain and range, domain, or maybe we should graph first, and then we'll come back to that. That might make more sense. Let's make a table of values. We put that vertex right in the middle, and then I'm going to surround it. So negative 1 and 0, negative 3, negative 4. Plugging in 0 yielded the negative 7, the vertex, or the y-intercept rather. So I know when I plug negative 4, I'll get the same. Now plug in negative 1 maybe. Negative 1 squared is 1, times 2 is 2. 8 times negative 1 is negative 8, minus 7. So 2 minus 8 is negative 6. Minus 7 gives us negative 13. Let's see, we're probably going to have to change the scale here because we're going by 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so let's go by 2s. I'm going to we'll change both the x and the y-axis to going by 2s. So I put little 2s there to denote that. So 0, negative 7. 2, 4, 6, so 7. So negative 4 is the same y value. And then I have negative 1, negative 13, 2, 4, 6, 8, 10, 12, so 13. So then negative 3, negative 13 also. And then negative 2, negative 15. 2, 4, 6, 8, 10, 12, 14, so 15. So there's my vertex. So now for the domain and range. Domain is the x values that you could plug in. It could be anything because the graph will continue traveling to the left and to the right forever, indefinitely. It keeps going higher and higher, but it still travels left and right. So we could just say all reals, all real numbers, or there's our symbol for real numbers. Now the range is different. It keeps going up forever, but there's a bottom to it, that minimum, which is the negative 15. So that's the lowest it ever gets. So we could say y is greater than or equal to the negative 15. It will never go below that. Number 2. So negative b over 2a. So negative, and then b is negative 5. So negative, negative 5, which of course will turn into a positive 5, over 2 times a. So 5 over negative 2. I can pull the negative out front and just call it negative 5 halves. So x equals negative 5 halves, or negative 2.5. So for my vertex, that's what I'm plugging in. So plug it in, square it, making special note that this negative is not inside of the square. So square the x itself. Square negative 5 halves. That's positive 25 fourths. And then there's a negative sign in front of it. So we get negative 25 fourths. You could also plug this in the calculator if you don't want to do it by hand. Negative 5 times negative 5 halves is positive 25 halves plus 3. Common denominator, negative 25 fourths plus 50 fourths plus 12 fourths. Negative 25 plus 50 is 25, plus 12 gives us 37 fourths. Now, having that as a decimal might be helpful. That looks like 9.25. 1, 2, 3, 4, 5, 6, 7, 8, 9. It looks like we don't have to change the scale for that one. It is opening down, so I don't think we need to change the scale. We can go by ones on this problem. That won't be a problem. That won't be an issue. Max or min, since it's negative, it's opening down. So the vertex is at the top, so it's a max. That max value is the 37/4, or the 9.25. Y-intercept, that's just the C, which is 3, so 0, 3. Let's make our table of values and graph before we do the domain and range. Vertex smack dab in the middle. Oops, 5 halves, not 5/3. Negative 5 halves, and then I get 37/4, which really, when I'm getting ready to graph it, maybe a decimal is helpful. So I'm going to call that 9.25, or 9 1/4. And then to surround that, maybe once again, maybe you'd rather have negative 2.5 written for your x also. You're welcome to do that. But I could add and subtract ones from 2.5, but I don't really like decimals. Maybe I want to skip over that. Maybe I want to go to, like, I don't know, -2, or maybe I'll go to -1 even, and 0. So to get from 2.5 to -1, -2.5, -1, I added 1.5. So if I subtract 1.5, that gets me to -4. That way it's symmetric, and then -5. The only reason I did this and not -2 and -1 is just because I wanted to get to the 0. I already know the y-intercept is 0, 3, so that just makes a little bit less work for me if I use that one. So then -1, or -1 squared is +1, then make it negative, so -1. -5 times -1 is +5, and then +3. So 4 plus 3 is 7. So -5, 3. -4, 7. And -1, 7. And then -2.5 and 9.25. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 1/4 is about right there. So for our domain, all reals again for the x, for the domain, the x values can be anything. Range, it has a max this time, so y can be less than or equal to that max of 9.25, or 37/4. Solve by factoring or square roots. The first one looks like I should factor. Looks like a -2 and a -5. So set each factor equal to 0, so we get 2 and we get 5 as our answers. 4, we need to bring that 81 over. So x squared minus 18x plus 81 equals 0. Looks like that's going to factor to x minus 9 squared. So then I can finish by square rooting, but I need plus minus. X minus 9 equals plus minus square root of 0. Square root of 0 is 0, and a positive 0 and a negative 0 are both the same thing. It's just 0. There's only going to be one answer in this problem, and that's going to be 9. Number 5, I'm not going to bother factoring this one. I'm going to probably divide by the 25, and then I can square root. So x squared is equal to 64 over 25. Square root plus minus, so x equals plus minus. Now the square root of 64 is 8, square root of 25 is 5, so plus or minus 8/5. Okay, and this next one, unfortunately, we've got a 4 there. So let's think about possibilities. Let's try a 2x and a 2x to lead the way, because those multiply to 4x squared. Maybe I'll try, let's see. I could try a 3 and a 2. One would have to be positive, one would be negative. I'd have a 6x and I'd have a 4x, which are not going to make a difference of 5. And so it doesn't work to switch the 2 and the 3 around and give me the same result. So if I think about 1 and 6, that's going to give me a 12 and a 2. That's not going to work either. So it looks like it's not a 2x and a 2x. Let's just try x and 4x. And I think we want the 6 to go over here and the 1 to go, no, sorry, well that's not going to work either. I was thinking it was a 2x there. Here I'm going to get a 6x and a 4x. That's not going to make a 5. Switching the 6 and the 1 around since I already tried it. It'll give me a 24 and a 1. That's not going to make a 5. Let's try 2 and 3. 8 and 3. There we go. Okay, so here I'm going to get a 3x and an 8x. I want the 8 to be the positive one and the 3 to be the negative one. So I get 8x minus 3x is 5x. Okay, so factors to this. That wasn't a very elegant presentation. I apologize for that. But now set each factor equal to 0. If x plus 2 equals 0, x is going to be negative 2. And if 4x minus 3 equals 0, add 3, divide by 4, I get 3/4. Okay, number 7, we get into a word problem. We're modeling. They give us the equation though, but they tell us they sell donuts for $1.25. They sell 450 a day at that price. They're looking at increasing the price by 10 cents, but they would sell 27 fewer. So they give us the equation about how much more should the donut shop charge per donut to maximize revenue. Okay, so we would we can choose to multiply this out, find the vertex by doing negative b over 2a, or we can graph it. It's kind of up to you. Let me show you using the calculator. So I can enter it just as it is, 450 minus 27x, 1.25 plus 0.1 x. I know I'm going to go right to my window because I know my window's going to need to be changed. X is how many times I'm increasing the price. I don't know. Let's maybe I'll go a little bit bigger. I might go like negative 15 to 15. I don't know what this should be. We can adjust that as necessary. The Y is the revenue. If they were getting $1.25 a donut for 450, we're talking about a lot of money. I'm going to go, and I don't know what the max is going to be, but I know I'm not going to make less than $0. But let's go up to like $1,000. And so I will go by 100s maybe for my scale. Let's graph this. We may need to adjust. Okay, we're not going to make it all the way up to 1,000, but then I could have went a little further to the right. But we're trying to find the maximum, and so I can see the maximum there. I'm going to use my maximum function under calc, second calc. Maximum is number 4. They're asking for the left bound. Now they'll ask me for the right bound, so move to the right, and then my vertex was somewhere between there, approximately there. Tells me my maximum is 2.08, 574. I'm going to go ahead and draw this. 2.08, we'll call it 574.22. I'm going to look at my equation just one more time, just to make sure I typed everything in right, because I was hoping that we'd have nicer numbers than that. Make sure I typed it all in right. 450 minus 27x times 1.25 plus 0.1x. Okay, that looks like it's typed in right, so I think I found the correct maximum. So now about how much more, not how much should they charge, how much more should they charge? So x was the number of 10-cent increases. So we should have about 2.08 10-cent increases. So this represents a multiple of 10. So we can multiply by 10, so about 20.8 cents. So maybe I'll call it about 21 cents. So we can round to the nearest penny. So about 21 cents is what we should increase it by. What is the maximum revenue that they'll make? Well, that would be the 574.22. How much more will each donut cost? Well, that was the question we just answered. Oh, sorry, about how much, not how much more. About how much. So add 21 cents to the $1.25. So $1.46 is what each donut should cost. How many donuts will go to waste on an average day? So I think what they're meaning by this, assuming, since they bake 450, so they're going to still bake 450. So how many will they sell? So if they're charging 208, how many donuts is that? So right here, forever we added 2.08. This 450 minus 27x, that's how many donuts they sell. So I'm going to plug 2.08 in there. I'll just do it on here. So it'll be 450 minus 27 times 2.08. So about 394 donuts basically is how many they're selling. So how many will go to waste if they're making 450? If that's 394, about 56 will go to waste. Now in the quiz, you may not be asked all of those things, but you may be asked something along those lines. Number 8, the length of a rectangle is 8 feet more than its width. So it's width plus 8. So we're going to think about that. Now the dimensions of the rectangle, its area. Okay, so the area of a rectangle is its length times its width. But instead of L times W, right, we could do that to find the area. But instead of L, we're going to plug in W plus 8. We're substituting W plus 8 in there. So W plus 8 is the length, but we're going to multiply that by the width, which is another W, and we get a total of 384. And we're going to find the width when we do this. Let's go ahead and distribute that W. So I'm going to come up here. W squared plus 8W. I'm going to subtract that 384 over. And so I wonder, I don't know if this is factorable or not. I'm doing a couple calculations just on my own, trying to find a factor. (16 and 24). Yeah, it looks like it is. So 384 is 16 times 24. I want the bigger one to be positive. So minus 16. They multiply to negative 384. They add to 8. Okay, good. So then my answers are negative 24 and positive 16. But we're talking about the width here. The width can't be negative 24, so I get to throw that out. So 16, we're talking about feet. And then the length, we previously said that the length is the width plus 8. So we need to add 8 to that, so we get 24. Okay, number 9, square root of 81 is 9. There's going to be an I there also because of that negative. No plus minus because we're not solving an equation. It's the principal square root. There's a positive in front of there because there's no sign, so I want a positive answer. So this one, 50, right out goes to 25 and 2. 25 goes to 5 and 5. So there's a pair of 5s. So I get to pull a 5 out. I have to pull an I out because of the negative, but this 2 is stuck inside a square root, inside the radical. So 5i squared of 2. Number 11, add the like terms. 4 and negative 7 adds to negative 3. Negative 3i plus 5i adds to 2i. Negative 3 plus 2i. And number 12, combine like terms. Remember it's subtraction. Negative 2 minus 4 is negative 6. And then negative 6i minus negative 6i. That's like negative 6i plus 6i, which is 0. So I just get an answer of negative 6. It's a little hard to read. Let me rewrite it. So negative 6 is my answer. Let's go to the back page now. Okay, we got some multiplying to do here. So 12i minus 15i squared. But there's an I squared, which is negative 1. So negative 15 times negative 1 is positive 15. So if I put in complex, as a complex number, I'd put the real part first and then plus 12i last. we got a FOIL here, so negative 10 minus 20i minus 6i minus 12i squared, that's going to become plus 12. Combine that with the negative 10, I get 2 minus 26i. On number 15, I've got to multiply by the complex conjugate. So I have 5 minus 4i in the denominator, so I'm going to multiply by 5 plus 4i, both to the top and the bottom. And I'll distribute in the top and in the bottom. I'll do the FOIL. So in the top, 15 plus 12i plus 10i plus 8i squared, but that's going to become a minus 8. In the bottom, 25 plus 20i minus 20i, up, so those will cancel. That's the goal of multiplying by the conjugate. Minus 16i squared, but that's going to become plus 16. So on the top, 15 minus 8 is 7. 12i and 10i make 22i. Over 25 plus 16 is 41. Now it says to write in in standard form, so let's to write the real part first. So write as a fraction, 7 over 41 plus, and then the complex part, 22 over 41i. 741st plus 22 41st I. Number 16 we're going to solve. I'm going to subtract that 35 over. Divide by 5, so x squared is equal to negative 7. Square root plus minus x equals plus minus. I'm going to pull an I out, and then 7 is prime, so there's nothing to pull out. So x is plus minus I square root of 7. Sorry, I didn't give much room. Okay, next one I'll subtract the 96 over. And so I'm going to take the negative 96 and divide it by 8. I'm going to get 12. Negative 12, rather. And so square root plus minus. Now with 12 goes to 3 and 4, and 4 goes to 2 and 2, so there's a pair of 2's to pull out. So pull a 2 out, pull the I out, the 3 stuck on the inside, plus or minus 2i squared of 3. Those are the answers. Number 18, find the value that would make it a perfect square, so cut 24 in half to get 12 squared, that I get 144. So C is to be 144, and then they want to know what it would be if I factored it. So then it would be x plus 12 squared. And then for the next one, negative 11 over halves squared is going to be positive 121 over 4. And so the factor is x minus 11 halves squared. Number 20, now we're going to solve by completing the square. Negative 14, half that is negative 7 squared is 49. I want a 49 here. Looks like I need to add 40 to both sides. Could have subtracted the 9 over and added 49 to both sides, but ultimately you're going to get this. So the left side factors to x minus 7 squared equals 40 square root plus minus x minus 7 equals plus minus 2 square root of 10, because that would have been 4 times 10, and 4 goes to 2 and 2, and then add 7 over. Number 21, since 5 is odd, I'm going to go ahead and just move that 7 over right from the get-go, because this is going to be a fraction that I add to both sides. So negative 5, cut that in half, negative 5 halves, square that, I get 25 fourths. So it's going to factor to x minus 5 halves squared, and this is 28 fourths, plus 25 fourths is 53 fourths, square root plus minus x minus 5 halves is equal to plus minus square root of 53 over square root of 4 turns into just 2. So add the 5 halves, turn this into one big fraction if you wanted to. Just put it all over 2, or you can leave it in this form. Number 22, I've got to divide everything by 3. Since it's an equation, I can just divide it. I don't have to factor it out. So x squared minus 8x. And then it's plus 9. Maybe you want to subtract that 9 over. Half of negative 8 is negative 4 squared is 16, so I want a 16. So I add 16. X minus 4 squared, 7. Square root plus minus. X minus 4 equals plus minus square root of 7. Add the 4 over. X equals 4 plus or minus the square root of 7. Number 23, I've got to bring this 7x over. Okay, so half of 8, so I'm adding 16 to both sides. X plus 4 squared equals, that's going to be a negative 8. Plus minus. X plus 4 is equal to plus minus. So I'll be able to pull a 2 out, an I out, and then I'm left with the square root of 2. So subtract the 4 over. X equals negative 4 plus minus 2i squared of 2. Find the discriminant first. I'm going to subtract that 5 over. No, I want everything on one side. So negative b, or sorry, no, sorry, b squared minus 4ac. So negative 2 squared is 4 minus 4 times a, which is 7, times 4ac, so negative 5. So it would be a plus 28 times 5 is 140. So 144. So now they ask me to determine what kind of answers. We don't have to find the answers. But if it's positive, which it is here, then we're going to have 2 reals. Okay, number 25, so I have 4x squared. Add the 3x over, so it becomes 6x. Subtract 3, so it becomes 9. Okay, so b squared, so 6 squared is 36. Minus 4 times 9. So 36 minus, so 4 times 4 is 16, times 9 is 144. So 36 minus 144 is going to be negative. Negative 108. And that makes it 2 imaginary. And then lastly, I've got negative 5x squared plus 10x minus 5 equals 0 if I put it in descending order. So 10 squared is 100 minus 4 times a times c. It's going to be negative 100. So 100 minus 100 is 0. That makes it 1 real. Make sure you've got it in descending order before you identify your A, B, and C. So now quadratic formula. 8 plus or minus the square root. Negative 8 squared is 64. Minus 4 times 1 times negative 17. Over 2 times 1. I'm going to do that discriminant. Negative 64 minus 4 times 1 times negative 17 is a total of 132. So 8 plus or minus the square root of 132 over 2. 132 becomes 4 and 33. 4 is going to go to 2 and 2, but 33 goes to 3 and 11, but there's nothing to pull out. So we get to pull out a 2 there. So 8 plus or minus 2 square root of 33 all over 2, so I can divide everything by 2. The denominator becomes a 1. The 2 that's in front of the square root of 33 becomes a 1. The 8 becomes a 4. So I get in total 4 plus or minus the square root of 33. Not a lot of room to work with here. Sorry about that. Next, x equals 1 plus or minus the square root of 1 minus 4 times 12 times negative 6. All over 2 times 12. So 1 minus 4 times 12 times negative 6 is 289. Was that divisible by anything? So I'm working on it just a little bit to see if I can find anything. Might be prime. Oh, no, it's 17 squared. Sorry, okay. I should have known that. 1 plus or minus 17 over 24. 1 plus 17 is 18. 18 over 24. They're both divisible by 6 to 3/4. 1 minus 17 is negative 16. Negative 16 divided by 24, they're both divisible by 3. Negative 16 divided by 3, or sorry, 8. I said negative 16 divided by 8 is negative 2. 24 divided by 8 is 3. Hopefully I did that right. And then lastly, I need to subtract this 4x over. So it's 8x squared minus 4x plus 1. Make sure you realize that b is a negative. So x equals 4 plus or minus the square root of 16 minus 4 times 8 times 1 all over 2 times 8. It's negative 16. Plus or minus, that becomes 4i. All over 16, I can divide everything by 4. 1 plus or minus I all over 4. Alright, last, number 30. Height of a ball thrown up in the air is given by that equation. How long until the ball hits the ground? So it's got this kind of function. Starts at the ground, and then it will land on the ground. Oh, it's from the, sorry, that's not quite true because it's thrown from the roof of a building. So it starts up here, and then ends up hitting the ground. There's more the picture that we have modeled here. I didn't catch that first part. But ultimately we want to know when it's going to hit the ground. I could go ahead and graph this. So negative 16x squared plus 64x plus 50, oops, plus rather. Okay, I probably forgot to change my window. I can go ahead and modify it and go down quite a bit. I could probably go down to like let's see. So that was 100, so maybe 150. I don't know, negative 8 and 8 or something like that. Okay. That's a little better. Okay. So I want to know when it hits the ground. It starts at right here on the roof and we throw it up, so we're not worried about this negative piece. But over here I want to find that intercept. Let's go ahead and use the intercept, or the 0 option on the calculator. So left bound, stay to the left of it, then move to the right of it. Goes off the screen, but that's right, come back to it, about there. So 1e to the negative 11, that's scientific notation for basically 0. Out over here I get 4.67 basically. So how long until it hits the ground? So about 4.67 seconds. Because the x-axis was our time. How long till the ball hits the ground? What is the maximum height of the ball? Okay, so I'm going to use graphing calculator to help me with that maximum also. So second calc, max is number 4. I have to go to the left bound, then the right bound. My guess, so 2, 114. So the question was, what was the maximum height? So the maximum height is 114 feet. And then when does the ball reach a height of 78 feet? So that's when I plug a 78 in place of the y. So 78 equals -6, because that's the height I want. So I'm plugging it in to evaluate, but I don't want to leave the 78 over there. I want to subtract it over so it's set equal to 0. Minus 28. I'm going to go ahead and put that equation in here. So I'm just going to subtract 78 from the 50, so it should say minus 28. Graph that. So it's the new zeros here. So there's 2 of them. So 0, I'm going to have to find them one at a time. So here I'm to the left right now. Can I get closer up? There, he went past it. So left bound there, come back to the right bound. Guess is about there. So 1/2, 0. So 1/2 of a second. And then let's find the other. Calc 0. Left bound. Right bound. About there. So in at 3.5 seconds. So those are when we're going to hit a height of 78 feet. On the way up and on the way down. And no, my graph wasn't perfect here. It should have been more like this, but that's all right. All right, thanks for watching.